morning everyone. I welcome you all in this session. As you are aware, in previous session we were discussing about how to calculate mean of grouped as well as ungrouped data. We have seen a method wherein we assigned code to different class intervals, and that is how we calculated mean in a better and faster manner. So, let us look at another mean which is called weighted mean. Now, the difference between weighted mean and simple mean is that in case of weighted mean we assigned different weights to different data points, while in case of mean we assign equal weightage. So, just to give you an example, let us say you are calculating mean of these two numbers 2 and 3. So, the mean would be 2 plus 3 divided by 2. So, we are giving 50% weightage to this and 50% weightage to this, right. That is what 1 by 2 means, right. Now, if you use weighted mean, then it is a kind of average where each data point is contributing differently, not equally, right. Some of the data points would contribute more than others. So, let us look at this example. There is an example in which there are 3 types of laborers: unskilled, semi skilled and skilled workers, right, or skilled worker laborers. Now, they are making 2 products, product 1 and product 2. So, the labor hours per unit of output is 1. So, to make one product or 1 unit of product 1, the labor requirement is 1 hour as far as unskilled labor is concerned, 2 for semi skilled and 5 for skilled. Similarly, to make 1 unit of product 2, the labor hours requirement is 4 hours for unskilled, 3 for semi skilled and 3 for skilled. Now, the question is, we want to calculate the average cost of labor per hour for each of these 2 products, right. What was the question? Question is how to find average cost of labor per hour. Now, if you go by the method which we have seen earlier, then you will simply calculate average of these 3, which is 7. So, you will say that the average cost of labor per hour is 7, but this is not a right answer. Why this is not a right answer? Let us say if this is the answer 7 hours, then for making product 1, how many hours you are requiring? Total hours 8 hours, right, 1 plus 2 plus 5. So, 8 hours. So, total hours required to make product to make 1 unit of product 1 is 8. The labor cost is rupees 7 per hour. So, the total cost would be 7 into 8, 56. Similarly, for product 2, total hours required for product 2 4 plus 3 plus 3, 10, right, 10 multiplied by 7. So, would we say that the labor cost of 1 unit of product 1 is 56 and for product 2 70? No, these 2 are wrong answers. Why? Because we have given equal weightages to all these 3 hourly wages, which we should not have done. So, there is a better method available and a correct method available. So, let us look at what is that method. We know that the total hours required to make 1 unit of product 1 is 8, right, this is 8, summation of all this is 8. So, what we will do, 5 into 1 plus 7 into 2 plus 9 into 5 divided by total hours, and this becomes 8. So, average cost of labor per hour is 8 rupees. Similarly, for product 2, How would you calculate? The total hours required for product 2 is what? 10, right. So, 5 into 4 plus 7 into 3 plus 9 into 3 divided by 10. So, this is 6.8. So, this is the correct answer, right. This is known as weighted mean. Now, there is a different method of calculating same weighted mean. What you can do is, this is 5 into 1 by 8 total number of hours, 7 into 2 by 8, 9 into 5 by 8. So, answer is 8. How would you do it for product 2? Just think for a while. This is 5 into 4 by 10 plus 7 into 3 by 10 plus 9 into 3 by 10, right. So, this is same answer you will get, and this is 6.80, right. So, either you calculate by this method or by this method. Okay. Now, let us move on to another type of mean, it is called geometric mean. So far we have seen arithmetic mean and weighted mean, right. Now, there are situations where quantities change over a period of time, and when the quantities change, you do not know what exactly the average would be. Of course, you can calculate average, but would that be correct? Let us take an example. So, let us say you have deposited 100 rupees in a saving bank account and you are getting 7% interest rate in the first year. Now, after 1 year, the bank has increased interest rate to 8%, then 10%, 12% and 18%. Now, we want to find out what is the average interest rate or what is the mean interest rate. So, let us solve this question. So, we know that the interest rate is 7% in the first year. So, growth factor would be 1.07. Growth factor means what? 1 rupee would become 1.07 rupees, right. So, 100 rupees would become 107, is not it. So, saving at the end of first year is this. Now, the next year interest rate is 8%. So, growth factor would be 1.08. So, this would be the saving at the end of second year. How did you get this number? How did you get this number? This is 107 into 1.08, right. You will get 115.56 and so on, right. You just calculate remaining values. So, finally, you will get 168 rupees at the end of 5th year, and initially how much you deposited? 100 rupees. Now, if you take the average of this growth factor, the average becomes 1.11. This is the one. It means 11%, because 1 rupee will become 1.11 rupees and 100 rupees would become 111 rupees, right. So, rate is 11%. So, we will say that the mean growth factor is 11%. Now, if you take this as answer, if you take for the time being this is your final answer and your mean growth factor is 11%. Now, if you let us take 100 rupees initially, your interest rate is 11%. So, you should get 168.51 rupees at the end of 5th year, but here how much we are getting? 168. So, we are getting 0.15 rupee less. It means this answer is not a correct answer. So, there is something called geometric mean which will take care of change in quantity over a period of time. One more inference is, since you should get 168.51 rupees, but you are getting 168, it means the mean growth rate has to be less than 11%. So, what is that value? How much less it is? So, for that calculate geometric mean, which is n under root of product of x values. You can write this in this form. So, 1.07, 1.08 and all other values growth factors. So, 1.18 to the power 1 by n, n is nothing but 5, right, there are 5 values. So, this becomes 10.93. So, the interest rate is 10.93, it is not 11%. So, if you use this particular method for calculating interest rate, it would be a wrong answer, right. So, the correct answer is 10.93 is the interest rate. This answer is a wrong answer. Okay. So, let us move on to next slide. So, we have seen weighted mean, arithmetic mean and geometric mean. Now, whenever what is mean actually, why we are doing all these things? Because we are measuring central tendency, right, is not it? We are measuring that point where the distribution rests, right. Now, we have seen mean. Now, mean is not a good measure of central tendency if your data is not normal. If your data set is normally distributed, then mean, mode, median all would be same, right. But in most of the cases your data would be non-normal, and then you will not have to use mean, you will have to use some other measure of central tendency, right. So, what is the problem with mean? It is affected by extreme values, which we have seen in previous session as well, right. It is tedious to compute, lots of data. So, first of all you take the average and it is a time consuming process. It cannot be computed in case of open class. When you have got grouped data, let us say your scale is, let us say your class interval is 0 to 5, 5 to 10, 10 to 15, and let us say these are different, and let us say 15 to next 15 onwards. So, this is your open class, all these are closed classes, right. This one is open ended class, 15 to 15 onwards, right. Now, it can be 15,000, right. So, you cannot compute mean if your mean is falling in this class. So, that is why mean is not a, and it cannot be calculated for categorical data, is not it. What is categorical data? Let us say male and female, right. You cannot have mean of male and female, right, you will not get any answer, right. So, these are couple of disadvantages of mean. So, how to overcome these disadvantages? So, let us look at another measure of central tendency, it is called median. Median is nothing but the middle point of the data set. So, let us say if there are 5 data points, then you should arrange them in ascending or descending order. In case of 5 data points, the third one would be the median, right. So, let us look at these data points. So, this is 1, 2, 3, 4, 5. So, median is this data point 3. So, median is 3, right. Let us look at another example. So, 1, 2, 3, 4 and 10, you just arrange them, and in this case they are already in an array form. So, the median would be 3, right. It is not affected by extreme value. So, this is the plus point of median, right. Now, so far as if you have got odd number of data points, then it is easy to calculate median, but in case of even number of data points, let us say you got 2, 3, 4, 5, how would you calculate median? In that case, you take this particular formula and it will give you the position of the median, right. So, n is equal to 4 in this case, right. So, 4 plus 1 by 2, this is 4 plus 1. So, So, this is 5 by 2, it is 2.5. It means median would be somewhere here, right, somewhere here, but we do not have that data. So, you just take the average of these two. So, that would be 3.5. So, median of this particular data set would be 3.5, right. So, this n plus 1 by 2 gives you the position of the median, not the answer to the question, right. If the number of value is even, the median is average of two middle numbers. Note that the value of the median, right, it is the only position of the median, not the answer or not the rank, right. So, I have already given you example. Okay. Now, how to calculate median for grouped data? The previous case was of ungrouped data. So, median is equal to lower limit of the median class, and what is median? Median is 50th percentile of the data, right, the middle value of the data point in case of even numbers, in case of odd numbers, but in case of even numbers, what is the median? N plus 1 by 2, right. So, total number of observations is equal to n, cumulative frequency of preceding class, right, m is cumulative frequency of preceding class of the median class, frequency of the median class and class interval of the median class, right. So, let us take an example and calculate median. So, there are 6 classes 0 to 1, 5 to 6, and you have also been given frequencies of each of these classes, right. So, this is 1 and this is 2. Now, we have to calculate median, right. So, solution to this example is like this. So, you have got frequencies of each of these classes, total is 25. Now, what is the median value? It is 50% of the data, right. So, 25 divided by 2, this is 12.5. So, where this 12.5 is lying in case of in this particular column, 12.5 lies here, right. So, this is your median class 2 to 3, right. Now, if you look at this formula, L is lower limit of the median class. So, that would be 2. Total number of observations are 25, right. So, n is 25, 25 by 2 is this, right, 12.5 minus 5, what is m? M is cumulative frequency preceding the median class. So, this is your median class, this is your median class, and cumulative frequency preceding this is 5. So, this is 5. 8 is what? F. F is frequency of the median class, which is this. So, keep in mind there are two frequencies. One is cumulative frequency of the preceding median class, and this is frequency of the median class, and C is class interval of the median class, which is 1, right. Class interval is 3 minus 2 is 1. So, if you put all these values in this formula, you will get 2.93. So, the median is 2.93. Let us say another example and we will find out median. So, this is the same example wherein we have collected data from 600 account holders in a bank, and we have seen their balance, right, and this is what we have seen in previous session as well, wherein we calculated mean. So, there were approximately 0 to 50 accounts where the balance was 78, the balance was 450 to 500, and there were only 4 such account holders. Similarly, there were 78 account holders who were having balance between 0 to 50. So, how would you calculate median? For calculating median, what you need? You need to first of all find out cumulative frequency, right. So, cumulative frequency is 78, then 201 and 388. you can calculate remaining cumulative frequencies. So, now this total value is 600, right, and what would be the median class? Our median value would be 300, right. So, 300 is falling in this particular class, right. This is the class. So, this is called median class, right, median class. Okay. What is the lower limit of the median class? 100. Total number of observations, of course 600. Cumulative frequency of preceding median class, this is 201. So, M is 201. Frequency of the median class is 187 and class interval is 50, right. So, this is how you can calculate answer to this particular question, and which would be 126.47, right. Advantages of median, of course not affected by extreme values, can be computed in case of open class if median is not in that particular open class, right. Can be computed in case of categorical variable. Now, this is important advantage. You cannot calculate mean of categorical variables, but here you can calculate median. To give you an example, let us say you have got, let us say there is a blade which is blurred, sharp and very sharp, right. So, this is your median, right. Let us say there are 3 people sitting. So, from this is a fellow sitting in left side, this fellow is sitting right side, and there is one fellow sitting in center, right. So, this would be the median, right. Only the disadvantage is you need to arrange data, and which is quite a time consuming process. So, to estimate population characteristics from sample, many times you will find that mean is easier than mean is easier than median, right. So, let us move on to next slide, wherein we will look at the third and final measure of central tendency, it is called mode. So, mode is nothing but the value that occurs most often, it is not affected by extreme value, just similar to what we have seen in case of median, used for either numerical or categorical data. So, this is again big advantage. There may be no mode, yes, it is a possibility. Let us say you have got 1, 2, 3, 4 data points, right. So, there is no repetition of any data point. So, there will not be any mode, and you may have a situation of multi modes, right. So, let us say 1, 1, 2, 2, 3, 4, right. So, there are 2 modes, right, 1 and 2, right. So, you can have several modes as well, right. So, you have got, let us look at this particular example. So, 1, 3, 4, it is appearing 2 times, right, 9 appearing 3 times, and so on. So, what is the mode? Mode is 9, right, because that data point is appearing for 3 times. Similarly, in this case there is no mode, right, because no data point is getting repeated. So, this is how you can calculate mode in case of ungrouped data. Let us look at mode for grouped data, and again let me remind, group data means data which are binded by, or the frequencies which are having different classes, right. So, you are grouping data by different class intervals and frequencies, that is grouped data. So, mode is equal to L, which is the lower limit of the modal class. Then you have got frequency of the modal class F1, F0 is preceding of the frequency of preceding modal class. So, this is very simple, 1 means frequency of the modal class, 0 means frequency of previous, right, 2 means the succeeding class. So, this is how you can remember. So, you need to calculate D1 first, then D2. D1 is frequency of the model class minus frequency of the preceding model class. Similarly, D2 is F1 minus F2. So, let us look at this question which is having different classes and frequencies. So, how would you solve this question? So, this is 25, right, some of the frequencies. Now, the model class is what? What is mode? Wherein you have got frequencies most, right. So, this is your model class. So, class interval is 1, right. So, L is lower limit of model class which is 2, right. F1, what is F1? F1 is, look at this slide, F1 is frequency of the model class. So, frequency of model class is 8. So, F1 is 8. F0 is frequency of the previous model class, right. So, this is the previous model class, a class previous to the model class. Similarly, 7 is what? Frequency of the next class after model class, right. So, this is 7. So, 8 minus 4, 4, 8 minus 7, 1, and C is what? Class interval, right, is not it, class interval. So, class interval is 1, right. So, this is 1, hence the answer is 2.8, you can easily calculate. So, let me summarize what we have done in today's session. We have seen how to find out weighted mean, we have seen how to find out geometric mean, we have seen how to find out median of grouped and ungrouped data, mode of grouped and ungrouped data. So, at the end of the day, which one will you select? It is mean, mode or median, that is the decision to be taken. As I said, if your data are normally distributed, then all will be same, but in real life situation you will have most of the times non-normal data, and in case of non-normal data you can say you will always have skewed data, whether it is positively skewed or negatively skewed. So, you should select median as the measure of central tendency. Okay. So, with this let me complete today's session. We will have few more sessions in which we will look at the measures of dispersions. Thank you very much.